Good evening. Welcome to Matlab Master Class Series Day 8. Firstly, I would like to thank IIT Mumbai for their cooperation and for their support. I would also like to thank you for your participation and thank you for your commitments towards learning. So, today is Day 8. So, it's fuzzy logic design using MATLAB. So far we have covered up 7 days and we have covered up some basics on MATLAB on the first day and image processing we have covered up, and video processing we have covered up some basics on video processing. Then we have gone through some medical image processing techniques, and we have also covered some graphical user interface development based on guide as well as the app designer. And yesterday we have covered up the basics of computer vision and using MATLAB. So today is fuzzy logic. So let us start into the discussion. So what is fuzzy logic? Right? So fuzzy logic. So what is the definition of fuzzy? Fuzzy is it's not clear and it's not precise and blurred. So that is fuzzy. So fuzzy logic is a way to represent the data in a clear manner. Okay, it's a representation of a complex if-else technique. So if you go for if you have more than 200 to 300 if-else conditions, then it is very hard to manage those conditions. So in that case, you could use fuzzy logic to represent the data in a clear manner. So it is just if-then statements. So I will tell you an example for a traditional if-else statement and a fuzzy logic statements. Okay, when you go for a traditional statement, like if you check this example, if speed equal to 0, then else speed is slow, else speed is fast. Okay, you have a condition like this. Whereas in fuzzy logic representation, it is represented as a fuzzy sets. You have to categorize the input in a linguistic variable, like if the speed is between 0.0 to 0.25, it's slowest. Then what is the output? If the speed is 0.25 to 0.50, it is slow, and 0.50 to 0.75, it is fast, and 0.75 to 1, it is fastest. If this is the input, then what is the output? That is the fuzzy rules. Okay, so that is the advantage of a normal if-else statement and a fuzzy logic statement. So whenever you have a complex inputs, like more than 100 or 200 inputs, for example, if you take diabetic classification, so there are a lot of parameters which the decision has to be taken. So in that case, fuzzy logic is the best option for classification of the data. So coming to neural network is fuzzy logic. Okay, what is the difference between neural network and fuzzy logic? So neural network is based on learning, so whereas fuzzy logic is based on classification. So classification in the sense it needs an expert system, like it needs an expert to write a rule for the system. Whereas neural network, it learns learns from its own data set. It has its own learning and it learns from its own data sets. Whereas fuzzy system, it needs an expert to write the rule for the system. Once the rule is framed, then it takes the decision based on the rule. And when neural network, it is very hard to modify the neural network systems. Like once the system is framed, you cannot modify the architecture. Whereas the fuzzy system, you could re-edit the rules. And fuzzy is more simpler than neural networks. So whenever you need a logic based classification or reasoning, then it is better to go with fuzzy logic. Whenever you need like learning kind of thing, like the input is getting changed, where you need to apply some common sense like a humans, then you could go with neural networks or machine learning or deep learning. So I'm not going to go much in detail into neural network or machine learning deep learning, as we have a separate session for this. So the components of fuzzy interference systems. Okay, what are the components of a fuzzy interference system? So it basically has 4 components. One is the fuzzification and interference engine, knowledge base, and defuzzification. So what is fuzzification? Fuzzification is you have to categorize the input with a linguistic variable, like if the temperature is low, medium, or high, and you have to choose the membership function for that variable. And membership function will have a range. You have to choose a range for low and medium and high for normal temperature control system. Similarly, you have to define the output also, like the fan speed should be low, high or medium. So that is defuzzification. Okay. So the input, categorizing the input is called fuzzification, and knowledge base is based on rules. Like you need an expert to write the rules for that. First they will create a knowledge base, like they will write the rule, like if the temperature is low, then the fan speed should be slow. If the temperature is high, then the fan speed is high. So that knowledge base will be designed by an expert. An interference engine will take the input and it will evaluate the rule. It evaluates the rule based on the knowledge base. And defuzzification is a process where it converts back the output. It gives the output. So these are the 4 rules, like the fuzzification, interference engine, knowledge base and the defuzzification. So knowledge base is nothing but framing of fuzzy rules, and interference engine is nothing but evaluating the fuzzy rules, and fuzzification is nothing but categorizing the input to the membership function and defining a linguistic variable to define the condition, and defuzzification again to give the defining the output in terms of linguistic variables. Okay. So when you should not use fuzzy, so whenever you need the systems to be learned, like whenever you need to apply some common sense kind of thing, then you should not use fuzzy. You have to go with neural networks. Wherever you could implement control kind of thing, like based on some sensor inputs or like that, in that case you could go with fuzzy logic. So where you have more number of sensor data and you want to take a decision, then fuzzy logic is the best way for implementing the control algorithm. So components of fuzzy, like say if you go in Matlab, so there are certain components of fuzzy interference system. The fuzzy logic designer will give you, with the help of fuzzy logic designer, you could add the inputs and you could add the output. You could change the type of the system. Basically, there are 2 types. One is the Mamdani based system and the Sugino based system. So you could choose the type of the system and you could choose the input. You could add the membership function. You could select the membership function on the fuzzy logic designer. The rule editor is the place where you could edit the rules. Okay, the if then condition, and you will be having operators like and or operators also. So the membership function editor will, where you could edit the membership function. You could have your customized membership function, or you could change the membership function. By default, there are a lot of membership function like triangular membership function, Gaussian membership function, trapezoidal membership function, so that you could choose the appropriate membership function for your own application. And the rule viewer can evaluate the rules. You could use the rule viewer. These 2, rule viewer and surface viewer, are only read-only tools. It is just used to evaluate the system. So if you could evaluate the system by using the rule viewer, and if you want to modify, then you could go for the rule editor and you could modify the rules. Okay, so that's a basic thing. So a fuzzy interference system will have a logic designer where you could create the inputs and you could create the outputs, and you could change the type of the fuzzy system, Hamdani or Sugino. Whereas the rule editor, you can edit your own rules. You can edit the rules based on the conditions. Okay, and the membership function editor is the place where you define the variable, like will define the fuzzy set for the inputs as well as the outputs. You could also have an option to change the membership type. Like you need a triangular membership type or a Gaussian type or a trapezoidal type, that you could change. So you have to choose depending upon your application. And the rule viewer is used to evaluate the rules. And once if there is a problem, then you could go to the editor and you could edit the rules and you could re-verify in the rule viewer. So once the system is done, then you could go for actual implementation. So these are the components of fuzzy interference system using Matlab. So fuzzy logic operators, you have and, or, not, and implies. So apart from if and then, you also have these operators to build a fuzzy logic system. Okay. So what are the steps to design a fuzzy logic control system? So first you have to identify the inputs, and you have to identify the output, and you have to process the stacks. Like what is the input and what is the linguistic variable. Like for example, if the temperature is it is low, medium or high, or warm, cold, or like that, you have to identify the variable first for the input as well as the output. Then once you have identified the linguistic variable, you have to configure the fuzzy sets and the membership function. You have to set the membership function. Once you set the membership function, then you have to form a rule for that. Once you form the rule, then you have to determine the defuzzification method, whether it is centroid or maximum or minimum. Then you have to test. Then you could go for testing the system and modify the system. So the application of fuzzy logic, like it can be used in automotive, like traffic light system or a transportation system or scheduling system. And if you take in medical image, it could be used for diabetic classification, or even image segmentation. You could use for image segmentation. In electronics, washing machine, air condition, so lot of control systems, wherever complex control is involved, you could go for fuzzy logic. Industrial also, like industrial systems, complex industrial systems, you could go with fuzzy logic. And it can fuzzy logic, it could also done pattern recognition and classification. So these are the some sample applications of fuzzy logic, but the application is much more, which I have not covered up here. So the next is, so today lessons is, we are going to design a traffic light control system from the scratch. So we are going to use a FIS editor. I'm going to explain you step by step how to create a traffic light control system. You could, by saying this, you could also implement your own fuzzy logic system. And this tipper system is the, which is the is a MATLAB example, which is by default it is in the MATLAB path. So I will also show you that how it works. So on saying these two systems, you can go through the fuzzy, you could refresh the fuzzy logic again, and you could design your own fuzzy logic design on MATLAB. So let us get into the MATLAB now. I'm opening MATLAB. First, I am going to change the path. Copy the path. Okay. CD space single quotes. I'm changing the path. First, I ensure that font is. I'm setting the font right. Okay, 24. Okay, so just type fuzzy on this command window. Okay, fuzzy on this command window, and this is the fuzzy logic designer. Okay, this is the fuzzy logic designer. This is the input. The left hand side is the input, and this is the system Mamdani. By default, it is in Mamdani system, and this is the output. Okay, this is the output. And here the name, the fuzzy interference system name will be here, and this is the type. Fuzzy interference system type is that. The first thing, you have to save this file. Then whenever you do modification, you save the file as like the normal program. Okay, file. So this new FIS is used to create new fuzzy interference system, or if import and export, you could also import a fuzzy interference system from a workspace or from a file. Okay, by default the extension will be .fis, FIS, as like M file. .m M file will be represented with an extension called .m. Okay, .m, and like this by this fuzzy interference system, by default it is the extension will be .fis. Okay, you could import a FIS file from the current working folder, or you could also import from workspace. You could import a file from the workspace. And similarly, to save the file, there is no option called save here. So instead of that, they have an option called export, to export to workspace or export to file. So I'll show you, like for example, I'm reading a FIS file, which is in the MATLAB by default, which is in the MATLAB. Okay, so you'll see help read FIS. Okay, read FIS. So this tipper file is in the MATLAB directory. So I'm clearing this variable. I'm going to clear the variable. Okay, FIS, read FIS. Okay, now I have read a FIS file. So I'm trying to open this file. import from workspace. You have to give the name FIS, okay, FIS which is in the workspace. So this is the fuzzy interference system for the tipper. Like it has two inputs, service food and the tip and the output, okay, and the tip. Okay, so this is to like import and export. So like you could import from workspace or import from file. If you have a FIS file, you could import from file. Okay, so export to workspace, export to file is to save the program. So first I'm going to export this file, export to workspace or file. I'm going to give an option to file. Okay, so I'm going to create a traffic light controller. So the file name is traffic. So now it changed, and the file name FIS name is also get changed. Is traffic. By default, this AND method or method implication will be min max. So you keep it on default, and only if you require some changes, like you could change this, but most probably you could keep this is on default. So first I will show you an example for traffic light control system. So traffic light control system, what are all the inputs? We have north. I am going to take 4 roads. Okay, so north, south, east, west. So what is the input? I assume the input from a video camera, which gives me 2 variables. Like one is the low density, another is the high density. Okay, so I'm not going to take medium density, so that we have time constraint. So I will take only 2 options. The density is low or high. I'm going to take 4 roads. So I have 4 inputs. So first thing is to add the input. Go for edit. You have an option to add variable. In that add variable, you have an option called input and an output. Okay. So add input, edit, add variable, add input. So totally I have 4 roads. No? So 4 cameras. So 4, I'm going to get camera. I'm going to get inputs from 4 cameras. So I'm giving 4 inputs. Okay. And I'm going to place lights on the 4 roads. So I'm going to have 4 outputs. So I'm editing add variable. I'm adding 4 outputs. Edit add variable output. Okay, 4 outputs. Okay, so I will repeat once again. This file import and export is used to open a file which is from the workspace or which is from the file which was stored in the MATLAB current root directory, from the current working folder or the root directory. The file name will be with extension .fis. Okay, it will not be a .m file. It will be with .fis extension. FIS stands for fuzzy interference system. Export is to save a file. I have exported to workspace. I have an option to export to workspace, which will be stored in workspace. So whenever you clear, it will clear the variable. So I want to store it as a file. So I have export to file. So if you go to the working folder, you have you got a file called traffic.fis, which is stored in the current working folder. Now, okay, now I'm going to design a traffic light system. So the traffic light system contains of 4 inputs. I'm going to place camera on 4 sides, and the camera, I assume that the camera will be the low or high. Okay, the camera may be low. The camera output may be that is low density or high density, and the output I'm going to place a light. Okay, so I have add 4 inputs here and 4 outputs here. Now you just click this input and change the name. North, south, east. Okay, I'm giving north, south, east and west. Okay, so I'm giving north, south, east and west. Similarly, the output also I'm declaring as this as north, and this is south. Okay, and this as east, and this output as west. So I have declared 4 inputs and 4 outputs. Now click this membership function. This is the membership function editor. Okay, here you want to create the linguistic variable like north. So north I'm going to have a low density and high density. So I have 3 membership function. So I am deleting this one membership function here for now, and I'm moving this to here like 0 to 1, and this mf1 I am renaming this as low. It means the traffic intensity is low. Okay, low, and this is high. The traffic intensity is high. If north, the intensity is low and the intensity is high. Okay, so low. So I am making this as 0. You could keep this one, and you could drag and drop like this. Okay, and high. Click this one and you can drag and drop this one. Otherwise you can also change the parameters. You could also change the parameters from 0 to 255. It depends upon the type of application you are designing. For image you could take 0 to 255. So this I am taking 0 to 1, low and high. Okay, for north I'm clicking south. Delete membership function 3. Okay, I have to make this as high. Okay, and this as low. Low, and this as high. Okay, north. Now south. I am deleting this membership function, and this is intensity. Intensity is high. Okay, and for this the intensity is low. Intensity is low and the intensity is high. Okay, this font cannot be increased here. I'm so sorry, this font cannot be increased, so you have to view on PC. So no way, this font cannot be increased here. So these menus, this is something which is out of my control. Okay, and east, I'm deleting this file. So this as you can drag and drop like this one. Okay, I'm giving this membership function as high, intensity is high, and this as low. It depends upon you could have more in membership function. Say for example, you have low. If you want to categorize again as low, medium and high, you could also have low, medium and high. You could have 3 membership function, or else you could add more membership function also. Based on that, the rule will be more complex and the accuracy will be more accurate. But due to time limitations, I am taking only 2 values, that is low and high, for the traffic. Okay, so south, low and high, and for north is also low and high, and for okay, so input is completed. So now output. So output, I'm going to have only 2 lights. One is green, another is red. So I'm going to delete this one. So I'm going to keep this as one. I'm keeping one as red and 0 as green. Okay, zero as green. For south, I'm deleting the membership function. Delete this one as red. Okay, and this as green. Green for south. So you have to give for all the 4 routes red. This is green. Okay, you can drag and drop this one. So it must be, okay, this is the range. You could also change the centroid value here. Like for example, if I'm going to give this a centroid value of 0, so it is going to change that. Okay, so you could also give the parameters value here. And this is west. West, you delete this membership function, and this you move here. Okay, this as green and this as red. Okay, green and red. So let me check green, red. Okay, green, red, green, red. Okay, so now we have completed the parameters for the input as well as the parameters for the output. Okay, so close. Let me export this file. Export to file. So it's just like save. Yes. Okay, so we have configured the inputs and we have configured the outputs. So if you click the inputs, you could verify which you could see the changes what we have done. Like we have 4 inputs: north, south, east, north, south, east, west. Similarly, output is also north, south, east, west. Okay, 4 inputs. Now we have to frame the rules for this. So go for editor. So add variable is completed now. If you want to remove the selected variable, you could remove. You could delete the variable. If you wanted, if you added something here, and if you want to delete that one, you could use this option: remove selected variable. Okay, and membership function, you could also add the membership function here. Membership function, which we have done like that. Rules. So this is the rule editor. This is the rule editor. So I want to frame the rules here. Again, there is no option to make the font size big. So let me check option format. No, there is no option to make the font size big. Okay, so I'm adding the rule. If north is low, okay, I mean if north is high, okay, if north is high and south is low and east is low and west is low, I want to allow north green. Okay, and make south as red and make east as red and make west as red. Add rule. Okay, now you got the rule here. If north is high and south is low and east is low and west is low, then north is green, south is red, east is red, west is red. You also have option called R option also. Instead of and here, you can also have an option R. Okay, I'm going to add the next rule. If north is low and south is high and east is low and west is low, I want to allow south is green, the rest is red. Okay, rest is red. Add rule. It's rule number 2. Okay, now if east is high and the rest is all low, north is low, south is low and west is low, now north I have to allow red and south is also red, east I have to allow green. Okay, and the rest is red. Add rule. Okay, so again the 4th rule: if west is high and the rest all low, then I have to allow the west is green and east is red. Add rule. So these are the 4 rules which I have added. You can add as much of number rules. I have seen fuzzy system which has more than 600 rules or 1000 rules like that. So you could add as much of rules. More the rules you have, the better the accuracy you got. So if you give the input which is not in the rule, definitely it is going to misclassify. Definitely it will misclassify. This system will not work if you give the input which is not in the rules. Okay, so you have to cover up all kinds of possibilities in the rules while you make the rules. Then you could go for a rule viewer. So here you could evaluate the output. See, if I'm going to give north as high, okay, the rest all is low. Okay, rest all is low. So you got the option is north is the rest all you got red signals, and for north you got the green signal. Okay, so you could evaluate the rules. For example, if north I am going to make it as a low and south I am going to make it as a high. South you got the red, green signals, for rest you got the red signals. Okay, so this way you could evaluate the rules possibilities. So I'm giving high. So now you got, see, you check here like east. So east you got the green signal, the rest all you got the red signals. Okay, similarly you could like this you could verify the rules. You could also check what happens if both the sides are red. Okay, both the sides are red. There is no rule for this condition. So it obviously it will give you the system will confuse to take a decision. So you have to give as much of rules to the system. Okay, close. I'm going to save this again, export to file, traffic.fs, replace. So far we have completed, like we have created the inputs and we have created the outputs and we have created the rules. Okay, I once again I will repeat this one. File, you have to import and export is to save the program. Edit, add variable is to create the inputs, to create the number of inputs. So in traffic light system we have 4 inputs, so we have created the inputs, and we have 4 outputs, we have created the 4 outputs, and I have renamed this inputs north, south. I have renamed the input here. After renaming, I click this input, I go inside the membership function editor. In that membership function editor, I want to define the variable, like define the linguistic variable. Like so if north, I'm going to take on the input side, I am assuming that the camera will give me the low intensity or high intensity. So the north low intensity, I have a membership function. For high, I have a membership function. So I have the range for the membership function. So the low intensity, if the range will be between 0 to 0.5. It means minus 0.32 for, if I check here, minus 0.4 to 0.5 is the low. For high, 0.3 to 1.21, that is for high. Similarly, I am evaluating this for north, south, east and west. Okay, and so for output, for green and red, I am taking 2 membership function and I am giving a range for the membership function for green and red. So once I create the membership function, once I create this membership function, then I'm going to frame a rule. You just go for rule, edit rules. There you have to give the rules. So once you create the membership function, you will get this window. If north is and south is and east is west and north, everything. So in order to move this window, there is a option to type, like click here. So this for navigation, to see all the membership function. You have an option to delete rule, you have an option to add rule, and you have the option to change rule. Okay, so of this rule, for example, if I want to delete this one, I could choose, say west is green. Okay, so I could delete the rule here. Then if I want to add it again, then just go for this. If north is low and south is low and east is low and west is high, then north is red, south is red, west is green. Okay, add rule. So I have added the rule now. So you have an option to delete rule, add rule and change rule. You also have an option to change the condition, whether it is or condition or and condition. Okay, or and. So this condition. So after changing this rule, close. Then I have export this file, export to file, which is stored in the folder here, traffic.fs. Now to evaluate this fuzzy system, I'm typing edit in the command window. Okay, so I'm typing edit in the command window and I'm reading the fuzzy interference. First I'm CLC and I'm going to clear the variable again. And I'm going to clear the variable. Okay, So I'm going to read the FIS. FIS stands for first interference system. So you could also have any variable name. It's just a variable name. You could give any name here. And traffic.fis. Okay, traffic.fis. I am reading this traffic.fis and typing help eval.fis. Okay, help eval.fis. You get a sample code here how to use that eval.fis. Okay, so eval.fis and y equal to output eval.fis of fis comma north south east and west. Okay, I have given this one. So to check here, north equal to 1, I am giving east equal to 0 and north south equal to 0, east west equal to 0. So I'm just declaring these variables. Okay, so we have the centered as 0.5, y greater than 0.5, 0.5. Okay, so this is the output. Okay, so I'm going to check now. Save the program, test fis. Okay, run the program. So save the program, run the program just for display. So 0 is green. Okay, and remaining all red. You got the output. Like for north is the intensity is high. For example, I'm making the south intensity is high. You got south is green. So now I'm going to make it as a simpler form. I'm going to take the input from the command window. Input enter the north intensity. Okay, so copy this code and I'm going to paste it here, again paste it here, again paste it here. So I'm going to change this as south intensity and this is east and this is west. Okay, this is west. Now I'm going to take this as index v value or index, any name you can give, index, just to identify which one is the main index value. Okay, 0 is green, 0 is green. So I'm writing a switch case over here, switch of index. Okay, case is 1 and case is 2 and case is 3. This is for north, this is for case 4 and end. Okay, so I'm getting the input from the command window eval.fis. I'm reading the fuzzy interference system which we created and I'm evaluating the fuzzy interference system, and this I'm applying like centroid. Okay, centroid is 0.5. So to just for to making is a binary. And min of y. So case 1 is north, case 2 is south. So this is north and this is south. Okay, and this is east and this is west. So I'm going to disp, just instead of toggling, I'm going to disp north is green. Okay, and disp south east. Okay, and west. I'm just, instead of toggling in LED, I'm just north is green. I'm just going to display on the command window red and east is red. Okay. So south, east and west. So the green should be here in, sorry, for east it should be green, should be here, and for red. Okay. Okay, this indentation you could change this indentation. Okay. So if you check now, I will explain the code. I will run the code and show the output, and I will explain the code. I am giving north intensity is 1, okay, and south intensity is 0, 0, 0. It means I want to get north is green and the rest is south. Okay, so again I am running test phase. So if north intensity is 0 and south intensity is 0 and east intensity is 1 and 0, so we got north is red and east is green and west is red. So if north is red, south is red and east is green and west is red. Okay, so I will explain you the code one more time. So I have used read fizz to read the fuzzy interference system. Traffic.fizz is a fuzzy file which we created there. If you want to open that fuzzy file, go to the command window, type fuzzy. Okay, type fuzzy. You will get the fizz editor. Once you got the editor, you just go for file, import from file. You have a traffic.fizz here. Open this traffic.fizz. You will get this window. So you could maximize this one, and here you could view this one. If you want to edit the rules, you just go for edit, click rules, where you could edit the rules and you could save the rule back again. Okay, save the rule back again. And if you want to do any changes, you could make the changes here. Once you've done all the changes, then go for file, export to file. You just give a name. I'm going traffic2.fizz. Okay, so give traffic2.fizz. This traffic2.fizz will be created here. Okay, so I'm reading this fizz. I'm reading read fizz is used to read the traffic.fizz which we have created, and I'm going to get input for the sensor inputs north, south, east, west. Input is the command which is used to get the command from the input from the command window. Okay. Enter the north intensity, enter this input, enter the south intensity, enter the east intensity. So I'm going to use 0 for low and 1 for high intensity. And eval fizz is to evaluate the fuzzy interference system. So eval fizz stands for evaluate fuzzy interference system. I'm giving this fuzzy interference system which I have taken from there. Okay. So eval fizz is used to evaluate the fuzzy interference system. So I'm reading the fizz file here on north, south, east, west. I'm passing that inputs. So y you will get the outputs. So 0.5 I'm using a threshold to make it as a binarization to binary value of only zeros and ones. So this min will give you the minimum index. It will. So I run the program. I keep a breakpoint here. So I'm giving the intensity for north intensity is 1 and the rest is 0. Okay. So north should be 0. So if you check y 0, in order to get this index, okay, so the index will give you the value like 1. So if south is index, then you will get index value 2. So I will show you the output for south. So 0, 1 and 0. Sorry, I made it wrong. So 0 is green. Okay, 0 is green. So I have to give 0. Sorry. So intensity should be high. So 0, high. Okay, 0 and 0. So if you check now, the index will be 2. Okay, so I'm writing a switch index. Case 1 is north and case 2 is south and case 3 is east and case 4 is west. So I have displayed here. So this you could give to like to any hardware, so where you could switch on the light appropriate lights for that. Instead of that, I have used a display command to display in the command window. Okay. So that's all about a fuzzy interference system. So I will explain you, like there is a basic example inside this MATLAB. Help. I will open the tipper file. Clear. Fizz of read fizz of tipper. Okay. So open fuzzy to open the tipper.fizz. So file import from workspace. So fizz is the workspace. Okay. Okay. So this example will be, by default it will be in the MATLAB. So here, like you could choose rules, edit rules. So there is a rule like if service is poor and food is rancid, then the tip is cheap. Okay. If service is good, then tip is average. If service is excellent and food is delicious, then the tip is generous. So these are the rules. So there are two inputs. One is service and another is food. Another is the output is tip. Okay. So you click service. In service, you have a membership function like poor. The service is poor. The service is good. The service is excellent. They have three options. Like food, the food is rancid. The food is delicious. Okay. The tip, they have cheap, average, generous. So based on these rules, you will get the output. Okay. This is an example in MATLAB. So you could go through this example also. With this, I conclude the session. So if you have any doubts, you post your doubts on the YouTube comment box, as well as the provision. You could comment it on the learn.pantech.net. So we have uploaded the video till like around day 6. Okay, only day 7 I think yesterday is pending. So with this I conclude this section. Thank you once again. Thank you for coming, and we will meet in the next session. Until then, bye bye. Thank you.